Hi, in this session we are going to cover the second electrophilic substitution reaction, and the name of the reaction is nitration. As you can see in this reaction, benzene has been introduced with a nitro group. So the product is called nitrobenzene. So this reaction is called nitration reaction. In this reaction you are using two things. One is concentrated nitric acid and the other one is concentrated sulfuric acid. Now do not get confused, we are not doing sulfonation once again. This sulfuric acid is acting as a catalyst and is being used in a very small amount. So nitric acid is the one which is acting as a reagent, and this concentrated sulfuric acid is simply acting as a catalyst. So in the end, benzene hydrogen would be replaced with the nitro group to give nitrobenzene, and the reaction will be called nitration reaction. So everything that I have told you would be written here in theory. I hope you were able to understand what nitration reaction is. So let us proceed to the mechanism, which is usually the difficult part for the students. So let us see step by step how the reaction will proceed. As you can recall, the first step is always the generation of electrophile. So here nitric acid molecule and the sulfuric acid molecule are going to react with each other. The sulfuric acid is a stronger acid as compared to nitric acid. So sulfuric acid is going to act as an acid and the nitric acid is going to be acting as a base, because acidity and basicity are always comparable actions. So nitric acid here is going to act as a base instead. It is going to accept a proton from the sulfuric acid and going to form conjugate acid, and the sulfuric acid is going to form conjugate base. Now in the next step you can display the whole second step, the second line. Otherwise you can simply omit this and do not write this as well. So do not write this part and do not write this part. Just simply show the dissociation of the conjugate acid from nitric acid and show this H2O has been removed and NO2 has been formed, NO2 with a positive charge, because this water molecule will remove such a way that it is going to take 2 electrons of this oxygen nitrogen bond and is going to form a neutral water molecule, and this NO2 is going to get a positive charge because this bond has been broken such a way that the 2 electrons has been transferred to oxygen and NO2 has received none. So that is why positive charge has arrived on NO2. Okay, so do not simply write this part and this part. You just simply have to show water molecule has been dissociated and NO2 has been formed. Okay. This is one way you can write, otherwise you can simply write what has been written here. Okay, so do not get confused at all. I'm simply, saving you some efforts. That is why I have gave you this suggestion. So this was the first step, generation of electrophile. This nitronium ion is going to act as an electrophile. So in the next step, your benzene ring is going to attack on the electrophile utilizing its pi electrons, and carbon nitrogen bond will form and a positive charge would appear in the benzene ring. So 3 resonance structures can be created and a hybrid structures can be shown. So this is going to be your second step. In the third step, your carbocation intermediate, which was formed in the second step, is going to lose a proton. So this will be assisted by the conjugate base of sulfuric acid. So as you can see over here, the conjugate base of sulfuric acid is going to help in removal of this hydrogen as a proton. This hydrogen would be removed as a H plus ion. So the carbon hydrogen bond electrons, the 2 electrons of this carbon hydrogen bond will be shifted back to the benzene ring. So this positive charge would be neutralized and the aromaticity would be regained. So this step is going to be a fast step, and you can see your final product, which is nitrobenzene, has been formed. So I hope this thing was clear to you. You were able to understand what nitration is and what is the reaction mechanism of nitration reaction. I want you to practice writing all these schemes and structures. Only that way you can attain mastery over the subject. So that is all for this session. In the next session we are going to start halogenation.